All right, we have to start talking about bearing, and bearing is the direction from a fixed point, and we have two ways that we can express bearing. If we give you a single angle, such as 190 degrees, we start north and we move in a clockwise direction. So 190 degrees, our first ray would go north, and 190 degrees means we have to pass through two quadrants. So we have a bearing of 190 degrees. If we had a bearing of 35 degrees, we're starting north, we're opening up clockwise 35 degrees. A bearing of 138 degrees, we are going to start north, go past the 90, and we're going to open up to 138 degrees. You could be noting that the supplement, this angle in here, is 42 degrees. That may help you. And let's look at a 328 degree bearing. So we need to open up clockwise 90 degrees, 180, 270, and then we need to go 48 degrees past that. So this would be a 300, I think I said 18 degree bearing. All right, the second way we can measure bearing is if we have directional bearing, and that means we're going to be giving you a north or south angle followed by an east and west direction. So notice that they're always positive acute angles. So our first one, let's graph north 42 degrees east. So we're starting north and we are opening up to the right 42 degrees. Okay, let's try south 31 degrees east. So this time I'm facing south and I'm opening up to the right 31 degrees. And we could also do north 40 degrees west. So north, and now we're opening up in a westward direction 40 degrees. All right, let's look at our first problem here with bearing. Two towers are on 20 miles apart, Tower A being due north of Tower B. A fire is spotted from the towers and its bearing from Tower A and Tower B are south 56 degrees east and north 34 degrees east. How far is the fire from Tower B? So the trick in doing these problems is to draw big, because it'll help you identify everything, and always draw your northeast southwest line to help you. So it says that Tower A is due north of Tower B, so that means this would be Tower A and this would be Tower B. We know that we have 20 miles in between the towers. So this is our 20 miles. And we know the fire is somewhere to the right because in both of these directions we're east. So let's start from Tower A. We need to open up south 56 degrees to the east. And then we need to start north and go 34 degrees east. So let's say this was 56 degrees. Now we are going to open up 34 degrees. We have to prove that we have a right triangle, and if we notice 56 degrees and 36 degrees are complementary, therefore my right angle is right here. I need to find how far the fire is from Tower B. So this point of intersection is the fire, so I'm finding this. We use SOHCAHTOA, and we could use either reference angle. So if we pick 34 as the reference angle, hypotenuse adjacent means that the cosine of 34 degrees is equal to x over 20. We multiply 20 times the cosine of 34 to get x, and we have x is approximately 16.58 miles. Now, if you used a reference angle of 56 degrees, then that would be the sine of 56 degrees is x over 20. And 20 times the sine of 56 degrees is x, which is approximately 16.58 miles. Okay, next, the bearing of a lighthouse from a ship 9.2 kilometers away is 32 degrees 30 minutes. Notice this is not directional bearing, which means we're going to be starting north and going clockwise. We need to figure out how far the ship must sail due north for the bearing of the lighthouse to be 122 degrees 30 minutes. All right, so the bearing of a lighthouse from a ship. Okay, so this would be our ship because it's from the ship, and it's 32 degrees 30 minutes. So that means we need to open north and go to the right 32 degrees 30 minutes. And our ship is going to be sailing due north. Okay? And when our ship gets to that spot, the lighthouse is now at a bearing of 122 degrees and 30 minutes. So I need to start north, go past the 90, 32 degrees and 30 minutes. Okay, so I know that this whole thing is 122 degrees and 30 minutes, which makes this supplementary angle makes it 57 degrees and 30 minutes. These two acute angles are complementary, which means this is my right angle. I have a right triangle, and I can use SOHCAHTOA. So I need to find how far the ship sailed north. So I'm trying to find that distance. If I use a 32 degree 30 minute reference angle, this is my hypotenuse, this is my adjacent, and this is my opposite. The one piece of information that I haven't used yet is that the ship is 9.2 kilometers away from the lighthouse when it starts. So that would be here. So I can now use the cosine of 32 degrees 30 minutes is equal to 9.2 over x. Variable is down, so I need to divide 9.2 by the cosine of 32 degrees 30 minutes, and x is approximately 10.91 kilometers. Again, if you use the other reference angle, the sine of 5730 is 9.2 divided by x, and you'll still get x is the same. Okay, next we have a surveyor who wishes to find the distance across a swamp. The bearing from one side of the swamp from point A to point B on the other side of the swamp is north 32 degrees west. The surveyor walks 50 yards from point A to another point C, such that line AB is perpendicular to line AC. From point C, the bearing to point B is north 68 degrees west. We need to find the distance across the swamp. So if we notice, it's saying from point A to point B, from point A to point B. So that means I have to go north 32 degrees west from point A. Point A must be down here, and point B is northwest. So point B would be over here. And I need to draw that such that it's 32 degrees off the north. Okay, so that would be 32 degrees. And if you have to, you can extend these lines if it makes it a little bit easier for you to draw. Okay, from here, the surveyor is going to walk 50 yards from A to point C so that AB is perpendicular. So if this is 32 degrees and I now need to walk at a 90-degree angle, I need to walk at a 58-degree bearing. Okay, So that this would be 58 degrees because I want that to be 90. And we walked 50 yards. From point C, which is right here, point B is northwest 68 degrees. So northwest 68 degrees. So this is 68 degrees. Okay, and now we have to do a little bit of geometry. We have a 68 degree angle here, and we have a 32 degree angle in green down the left. So that 32 degrees will move to be 32 degrees here. And this 58 will move to be 58 here. So in order to complete a 90, this would be 32 and this would be 22 to complete each quadrant. This would be 36 and this would be 22. All right, we have everything set and all we have to do is find this distance. So this is our hypotenuse. You can use, this is our reference angle, so that's adjacent, and this is opposite. So the tangent of 54 degrees is equal to x over 50. 50 times the tangent of 54 equals x. X is approximately 68.82 yards.